Hey y'all. Oh, I didn't know it started. Okay, so I don't have these problems already written out. I do on my piece of paper, but we're just going to actually write them. Okay, let's do a new. I had that. You know what? Nope, I'm just going to do a new one. Never know when you might need to refer to something. And didn't even save it, so, probably delete anyways. Come on, people. There we go. Okay, so this is up 12.6. I'm real zoomed out. Wow, I'm real zoomed in. I give up. I say I give up, but I'm going to keep trying like I always do. 12.6. Okay, y'all. So this is called special products. Okay, I think I may have referred to it in the last video as like special factors. Factors is usually going to be how it'll look originally, and then we'll go ahead and we'll do the multiplication, which is why it would be called product. We will do a few things where it starts a certain way. I think it's probably in the next section. And what we'll actually do is end up turning it into factors. Factors is going to be like when you have sets of parentheses. Each set of parentheses considered a factor. So let's go and get started on our special products. Y'all, this one, I'm going to go and write a few things. It's probably not going to make a lot of sense. You're going to have it in your notes so you can refer to it whenever we're doing these problems, okay? I get it if at first you're like, I have no idea what's going on, but just keep watching. So if you see something in parentheses written like this, A plus B, and then say it's being raised to a certain power. It doesn't have to be squared. It could be 3, it could be 4, it could be any type of number, okay? What I'm going to do is I'm actually going to change it to 2 so that I can show you how you would square it, okay? If you see something inside of parentheses and it's got a 2 on the outside, that's our exponent. So what we looked at in 12.1, this would be the whole base. The whole parenthesis, A plus B, is our whole base. So what you do is you actually take A plus B times A plus B. That's why I didn't want to keep it as M, because I didn't want you to think that it only applies to like certain numbers. Y'all, if that was a 3, I would write it again. Okay, does that make sense? That's why I'm using 2 to show you this. Please keep in mind, I did this in one of the videos. This does not, will not, and can never, ever equal that. Okay, and that's because the correct way to go about it is to actually, what it's called is to expand it. This would be considered a condensed version. This is expanding it, writing it in a longer version. And as always, they go back and forth. If you have the 2 factors written next to each other and they're the exact same thing, you can condense it and write it as 1 factor and just put the squared exponent there. Just like if you have it as a factor, right, set of parentheses, and it's being squared, you can write it 2 times. However many times. If it's being cubed, you write it 3 times, so on and so forth. 4 is 4 times, like it's literally telling you to multiply A plus B, that whole parenthesis, by itself, the number of times your exponent says. Okay. If we have, so this is like similarly, if that's an A minus B, you write this. Remembering that you would never just do that. Okay. Let's see, what else do we have here? Okay, there's another form that you will see in this homework in this section. Say we have a number multiplying, and then I've got, y'all, I'm going to do A plus or minus B. Okay, I could have done the same thing here for this one, but I went ahead and I wanted to show you. Do you see how they each followed the same thing? I just wrote it twice, right? That's why I had the ability to do plus or minus right here, but I went ahead and broke them apart so you could see. If I do write this, that means that they can be written both ways like this. Okay? I just think that mathematicians, I think that math professors, I think that we're all just kind of inherently lazy. Okay? If we don't have to write something multiple times, we're not gonna. So what this would mean is that, like I said, there'll be two different ways that this can be written. I could do C, and then I'm going to go ahead and expand this. So it's saying keep your constant, right? I use C as a constant. Keep your constant out in front. Sorry, don't hate me. I forgot my thing because I explained the plus or minus. Say it's being squared. Keep the constant out in front. This being squared means you can write it 2 times. Okay? It's literally what it's saying. I've got A, either a plus B, or I've got A minus B. That's what the plus or minus means. It's either or. And so what you would do is you would write that factor 2 times and you got your constant out in front. Okay, so we've got that. This is, okay, y'all, I did a video, last video I did, and I did a little asterisk. This is like problem 9. And I was like, y'all, this is, kind of where we're going whenever we start doing the special stuff. And if it's written a certain way, it means it can be written another way. It's called difference of squares. That's what we're going to have right here. So I'm going to write the more complicated looking way and then show you how it can be written if you have that form. Okay, so if you have, actually, let me do this. I'm going to do it on this side, y'all, just so it kind of makes a little bit more sense. Okay, if you have something divided by 2, so you have like half of it, right? If it's still written in a fraction, that's okay. And we have, say, minus a b over 2 multiplied by a over 2 plus a b over 2. So notice here, a and b, right? Each over 2, right? This is the important thing. But these signs are different. Here I'm saying it's either plus and plus, or they're both minus or minus, right? That goes along with that very first chunk we did when the video first started. The difference here is I've got the same a over b and a over b. A over 2 and a over 2. B over 2 and b over 2, right? They almost look exactly identical except for those signs in the middle are different. That means that this can be written as a squared minus b squared. This is that asterisk from earlier. Okay, this is what we call difference of squares. Y'all, formulas are usually quite literal, right? They're static. They don't change. They are what they are. And they say exactly what they need to say, nothing more, nothing less. Do you agree with me that this is a squared term? This is a squared term. This is a difference symbol. That is why this is called a difference of squares. Okay, so we will see something like that. I think I did explain it here. I'm just going to go ahead and kind of reiterate it. If this was a 3, I would write another factor, right? If it's a 4, I write another factor. Just make sure you keep that in mind. I think this homework may even show a 4th power. You write it how many times? 4 times. The exact same thing 4 times. Okay? So now let's see what we have here for some examples. Example number 1. Example number 1 is in parentheses x plus 6, close parentheses, and squared. What does this not equal? This does not equal x squared plus 36, right? Like that was made very clear. You can't do that, like at all, okay? What we do is you write, remember the parentheses are called factors. You write the factors 2 times because it's based off of that exponent. And then we've seen this before, y'all. I've got 2 binomials multiplying each other, right? So what do? FOIL, first, outer, inner, last. First, outer, inner, last, also known as multiply everything on the left-hand side to everything on the right-hand side. What do I get? X squared plus 6x plus 6x plus 36. These are like terms. x squared plus 12x plus 36. And because x times x is x squared, right? Keep and add. 6 times x is 6x. 6 times x is 6x. 6 times 6 is 36. Combine like terms. So if I have the factor x plus 6 being squared, that is the answer to it. Make sense? Okay, let's do the second problem. We have in parentheses x minus 3 being squared. I know for a fact this is not x squared minus 9 or x squared plus 9, or you can't do that. Actually do the work. Write it out. It was condensed. Now we've expanded. FOIL. X times x is keep and add. X times 3 is 3x. Signs are different, so it's negative. 3 times x is 3x. Signs are different, so it's negative. 3 times 3 is 9. Signs are the same, so it's positive. Combine these like terms. Didn't do anything here. Bring it down. -3, -3. Add and keep. Keep and keep. +9. Didn't do anything. Bring it down. If I have the factor x minus 3 being squared, that is your answer. Does that make sense? Kind of just rolling a couple things together. The fact that I have a base raised to an exponent, that means multiply your base. The number of times your exponent says 2, that's 12.1. I have FOIL, right? I just got binomials multiplying. That's 12.5, I believe, 12.5. And then combining like terms, that was 12.4, right? Combining all the different terms together if they're alike. And then that's it. That's your answer. Okay, let's do problem 3. It looks like this. Oh, it looks like this. X minus 1 over 4. It's a negative 1 over 4. X plus 1 over 4. It's a positive 1 over 4. I'm going to go ahead and do the FOIL just because I want y'all to see something. This is another asterisk problem. Okay, this is one of those important ones. So let's do the FOIL. My first two terms are x. X times x is keep and add, right? And then x times a 1/4. Well, that's a 1, right? That invisible 1. 1/4 times 1 is 1/4. Signs are the same, so it's positive. Don't forget your variable. Let's do this multiplication. 1 times 1/4 is 1/4. Signs are different, so it's negative. Don't forget your variable. 1/4 times 1/4. 1/4 times 1/4. Multiply straight across the top, straight across the bottom. I get 1 over 16. Those signs are different, so it's negative. Question. What do you notice with those two terms right there? Are they additive inverses? Are they the exact same term with different signs? They are. Those go away, right? These, I wanted it to still be red. Those cancel each other. The only thing I have left is x squared negative 1 over 16. Do you agree with me that that is the same thing as a squared minus b squared? A difference of squares, right? A squared minus b squared. Well, let's look. Look at our original problem. My x's, they are in place of my a, right? My b, that's my 1/4. I'm saying that if I have the exact same things multiplying each other, the only difference is their signs, that I can immediately write it as that difference of squares, which was a squared minus b squared. So what's my a? X? What is it if I do x squared? Well, it's x squared. What is my b? It's 1 over 4. If I take my b and I square it, I can apply that exponent rule where the top gets squared and the bottom gets squared. 1 squared is 1, 4 squared is 16. Do you notice that I got 1? Oh, man. That I got 1 over 16? And then what does the formula tell me? It tells me that if I have the a over 2 minus b over 2 and multiplied by a over 2 plus b over 2, I can do a squared, I can do b squared, and I put a negative sign in between them. What's right here? A little negative sign. So technically, long story short, if you have something that is an expanded version of difference of squares, your middle terms are going to cancel each other out, which means if you want, all you have to do is just square your a, square your b, put a negative in between them. That's what it's saying, okay? There's absolutely nothing wrong with doing the FOIL, canceling your middle terms, and just having your first and your last term. But I just wanted to make it very clear that what we're doing here is called difference of squares. If you see something that says difference of squares, okay, it's going to want you to understand that they're the exact same thing with different signs, and they can just be written in this form, okay? Let's do one more, and then I'm going to start another video, okay? That was problem 3, which makes this problem 4. 5x plus 4 times 5x minus 4. Do y'all see what I see? Do you think that the 5s could have been gotten by taking half of a square, right? Remember? It doesn't matter, y'all, which one has the negative and which one has the positive, okay? Just so y'all know. That equals a squared minus b squared. If you have this, you can write this. That's actually what I'm going to do here, y'all. Look at my blue parentheses up top right. Exact same thing, but they have different signs in the middle. 5x, 5x, same. 4, 4, same. Positive, negative, those are different signs. I can apply this formula. And what this formula says is that they're going to be coming from a square. So in order to know for sure that it's a difference of squares, let me look. If you do 5 and 5, what do you get? 25x squared. That matches that. That's something squared, right? 25 is a square. It's a perfect square. And then my x is being squared. Now let's look at my 4s. If I do 4 and 4, do I get a perfect square? I do get a perfect square. I get 16. And then formula, put the negative in between. You're done. Let me go ahead and I want to cut that and I want to paste that right here. Okay. And then let me kind of clean that up a little bit. That's the answer, right? And I get it. I get that you're just like, I have no idea what this woman's talking about. This is why it works. Let's actually do the FOIL. 5x times 5x. 5 times 5 is 25. Signs are the same, so it's positive. X times x, x squared. 5 times 4 is 20. Signs are different, so it's negative. X times no x is x. 5 times 4 is 20. Signs are the same, so it's positive. X times no x is x. 4 times 4 is 16. Signs are different, so it's negative. What do you notice right here? Additive inverse is right. Same exact term, different sign. That means they cancel. They go away. I mean, signs are different. Subtract. What do you get? 20 minus 20 is 0. 0 times x is 0. Like it goes away. So what do we have left, y'all? We have a 25 x cubed, and we have a negative 16. Are those the same? Yes, they are. So, again, there's nothing wrong with doing the FOIL, combining your like terms. You'll notice the middle ones will cancel. I believe with practice, after a while, you'll really see like, whoa, hold on. 5 and 5, that's 25. That's a square. 4, 4, that's 16. That's a square. Hold on. Different signs. Boom. Like, let me just literally, y'all, multiply these two together. And then multiply these two together and throw that negative in between them, right? I don't know what else I had deleted there. Okay, so that was expanding using the fact that we had exponents on factors whether it's positive or negative on the inside, you need to expand. Remember I told you that if you have a constant outside of a factor that needs to be expanded, like it's being squared, square the factor, right? Write the parentheses twice, FOIL if you need to, and then what you do lastly is distribute that constant through. We did a difference of squares problem, and we just did another difference of squares problem. Usually you'll see it in this form, and we're going back to this form. In this section, they're giving us the left-hand side, right? The way I wrote it here. They're giving us that left-hand side, and we're writing it in that right-hand side. Again, though, do FOIL. It's not a problem. Later, what they'll do is they'll just give it to us in the a squared minus b squared. And our goal is to write it in the expanded form with the parentheses, okay? So hopefully that'll make sense then. If you have a factor that's being cubed, I will do one like that really quick, okay? If we have a factor, I don't even know what problem we're on, that's being cubed. Say we have x plus 3 cubed. This is 1, 2, 3. What you do is you multiply them all. This times this, this times this, this times this, this times this. We would get x squared plus 6x plus 9. And then look, bring this down, x plus 3. Then we would do more of the multiplication, where you take everything in the left-hand side and multiply it to everything in the right-hand side. Everything. Okay, so I'm just going to do this. We get keep and add a positive 3x squared. We get a positive 6x squared. We get a positive 18x. We get a positive 9x. We get a positive 27. We get x cubed plus 9x squared. What is that? 27 plus 27x plus 27. That's the answer to having that factor being cubed. Okay, well, if you have any questions, make sure you ask and let me know. Also, if you have it to the fourth power, write your factor. Right? Factors are sets of parentheses. Write your factor out 4 times. You do the multiplication starting from the left with 2 factors. Write your other factors down. Do your multiplication again. Write your other factors down. Do your It's going to be a whole bunch of multiplication. I don't think but maybe 3 or 4 on the homework, and they are a little time consuming, but it is actually really, really good to like strengthen your skills, okay? So make sure if y'all have any questions, you ask and you let me know. Thanks, y'all. Bye.